Hello, Lacy students. This is Miss Marsh speaking. Today we're going to look at inverse matrices. So your learning goals for this particular video, I can find the inverse of a 2x2 matrix and I can find the inverse of a 3x3 matrix. First thing that we got to talk about though is what's known as the identity matrix. An identity matrix is basically a matrix with ones on the main diagonal and zeros everywhere else. So it looks like those two below. This would be a 2x2 identity matrix because there's just ones on the diagonal. This is a 3x3 identity matrix. It's basically like you would be multiplying by 1 with normal numbers. So basically if I multiply any matrix by the identity matrix, you get the same matrix back out. Why are we looking at this? Well, basically to use the inverse matrix, what you're going to do is find a matrix that when you multiply it by another matrix, you're going to get the identity back out. So the inverse of a matrix is basically it undoes a matrix. Kind of like what we divide by a matrix or divide by a number. Well, we can't divide matrices, but we can multiply by what's known as the inverse of a matrix. So basically it's like adding a negative number to its positive or multiplying by the reciprocal. It's going to get you 1 or 0 depending if we're adding or multiplying. We're going to notate inverses by using a -1 in exponents. So a to the -1 would be the inverse of a matrix A. So just be kind of aware of that -1 notation, alright? So to find the inverse of a 2x2 matrix, we're going to do the following. We're going to change A and D around. So basically A and D are going to flip spaces. So you see how D is now at the top and A is at the bottom? Then we're going to change the signs on C and B. So basically if it was positive, it's going to become negative. If it was negative, it's going to become positive. Then we're going to find the determinant of the original matrix and scalar multiply by it. So this is basically right here, this is the determinant of A. Alright? And we're going to do 1 over the determinant of A. So let's try a few problems here. So I need to find the inverse of these matrices. So basically, let's find the inverse. So a to the -1 is equal to, let's find the determinant. So -2 times 8 is -16. -9 times 2 is -18. So it looks like my determinant is 2. So it's going to be 1 over the determinant to multiply, so it's going to be 1/2. Now, we get to flip-flop A and D around, so D and A are flipped, and then change the signs, like that. Now, you're going to scalar multiply this 1/2 in, so basically he's got to go and talk to every single buddy inside. So, 8.5 is 4, -2 times 1/2 is -1, 9 halves, and -1. Not too bad, right? Let's try it with B. So B to the -1, or the inverse of B, let's find the determinant here. 1 times 3 is 3, minus 2 times -1, which is -2. Add those two together, it looks like I get a determinant of 5. So my scalar in the front here is going to be 1/5, because it's 1 over what my determinant was, right? Let's find our new matrix. So flip-flop A and D around, then change the signs of the other two. Now, let's distribute that 1/5 in. So we're going to get 3/5, 1/5, -2/5, and 1/5. Your inverse matrices are most likely going to be kind of gross, just because of how they are set up. Usually your fraction in the front is going to be a fraction, not a nice number. So assume you're always going to have kind of a silly looking inverse one, okay? Now, 3x3s. Finding the inverse of a 3x3 is way too cumbersome. Ooh, that should be way two O's on there. We will use our graphing calculator skills to find a 3x3 matrix's inverse. So you're going to want to pull out your graphing calculator, and you're going to want to type a matrix into the matrix part of the calculator, like we've been looking for determinants, and then you're going to select the matrix and take it to the -1 power. I'll show this in class to you guys as well, so you guys have an idea of how to do this. So, but until then, if you want to actually try it on your own, I have this 3x3 right here, and I need to find the inverse of it, Well, quickly, I did this on my calculator, so I typed my 3 by 3 matrix in right here, and then I selected that matrix and I took it to the power of -1. Well, this is what I got back out for my inverse. I got 3, 1, 4, -5, -2, -6, -1, -1, -1. Now, are there ways to do a 3 by 3's inverse by hand? Yes, but why would you do it when the calculator can do it for you? It takes so much longer to actually do a 3 by 3's inverse by hand. If you want to see what that looks like, I'll definitely show it to you. But it's very, very time consuming, and I found it easier when I learned how to use my calculator to use the calculator because I wanted to save time. And that's the end of this video. See you later, Sabers.